Yeah. Question number 1. 3 5 ohms resistor connected in parallel have a potential difference of, come over here, of 60 volts applied across the combination. Full stop. The current in each resistor is A, option A is a 4 amp, B 36 amp, C 12 amp, D 24 amp. Let's repeat the question again. 5 ohms, that means 5 ohms is to 3 5 ohms resistor connected in parallel have a potential difference of 60 volts applied across the combinations. Full stop. The current in each resistor is A 4 ampere, B 36 ampere, C 12 ampere, D 24 ampere. Solution. Ohm's law states, Ohm's law states that the current I flowing through a metallic conductor is always proportional to the what? Potential difference between its ends. Is always proportional to potential difference between its ends, provided the physical condition. What's the physical condition we are talking about? Temperature of the what? The metallic wire is what? Constant. Means what? Provided that what? Physical what? Physical condition, which one of them is what? Temperature, etc. of the conductor remain unchanged. That means remain what? Constant. Ohm's law, which we call George Ohms, the person that discovered it is German physicians, which is called what? George Ohms. That is one that discovered the relationship. He said that's why we use his name and in remembrance of him by saying Ohms. That's what we say, Ohms. Ohm's law states that the current I flowing through a metallic conductor is always proportional to the what? Potential difference between its what? End. Provided that physical what? Condition is what? Remain what? Constant. And I say mathematically, this means that what? Voltage is directly proportional to what? Current. And the voltage is equal to what? Current times what? R. Then what is this R? This R is the constant of proportionality, which makes us to have equals to. For us to have a proportion, there must be a constant of proportionality, which will make us to have what? Equals to. This constant of proportionality, which we call what? Resistance, is a constant. And when I say where resistance is, where R is a constant of what? Proportionality, known as the electrical resistance of the conductor. Electrical resistance of the conductor. When I said the value of this electrical resistance of conductor depends upon the nature and the dimension and the temperature of the word conductor. And what do you mean? This electrical resistance depends on the nature. What do you mean by nature? If you have good wire are more pure in the sense that it has negligible resistance. If you use a gold as a wire, that means the resistance that gold will offer is negligible, but it has no what? Resistance. Then when you use silver now have a resistance. Then when you use copper have more resistance than silver. When you use other metals less than what? Gold and silver, they have higher resistance due to impurity inside those what? Metal. Why do they have resistance? Due to what? Impurity. So the resistance they will offer to the flow of current will be higher than the resistance which the what? The copper or silver will offer if we are using silver metal. Therefore, we now say it depends on the nature of the what? The metal. Then dimensions of the conductor. We said it depends on the nature of the what? Who depends on this nature of what? of the what? Conductor. Resistance. Resistance depends on the nature of the conductor, which I have explained to you that gold is more pure, therefore it offer low what? Resistance to the flow of current. That in fact it offer low what? Resistance, because it's more pure gold. If we use gold as metal for conductor. Then followed by what? Silver. If we use silver, silver have a little resistance. Then if you now use copper, you have what? More what? Resistance compared to what? Silver. Then if you now use aluminium will now give you more resistance compared to what? The copper. Therefore we said depends on their nature. Have you seen where the nature come over? Then we now come here, dimension. That this resistance depends on dimension of the conductor. Therefore if you now have a wire that has higher cross-sectional area, you know this is the wire now. If I have this wire like this is wire now, we have this, then this now is what we call cross-sectional area. If I have the wire that has this small cross-sectional area, you will now see that this wire will what? Offer more what? Will have offer less resistance compared to this one. This wire that have higher cross-sectional area, look at the cross-sectional area. This man that have higher cross-sectional area compared to this man will have lesser resistance compared to this one, to the flow of current. This man will have lesser resistance to the flow of current compared to this man. You will not see that the lesser the what? The cross-sectional area of the wire, the more the resistance. But let us see the relationship. We say that resistance of a wire is directly proportional to the what? To the length of the wire, and inversely proportional to the what? Area, cross-sectional area. The resistance of a wire is directly proportional to the length of the wire, and the what? Inversely proportional to cross-sectional area. You will not see the higher the what? The cross-sectional area, the lesser the what? Resistance which the wire will offer, which that wire will offer to the flow of current. You will not see the lesser the cross-sectional area, the higher the resistance which the wire will offer to the flow of current. Do you understand it from here? You will now see now that this man is directly proportional to the what? The length of the wire. The more the length of the wire, the higher the what? Resistance that wire will offer. Then the higher the what? The cross-sectional area of a wire or conductor, the lesser the what? The resistance it will offer to the flow of current. Have you seen what we're talking about? That's what brings us to what we call dimension. This is what we call dimension. The higher the what? The cross-sectional area. Cross-sectional area of the wire is the dimension of the wire. Then we will now say that resistance depends on the nature of the wire, which I have mentioned, gold, silver. Then now here it depends on the dimension, which we will now mention what we call cross-sectional area. Then it depends on the temperature of the what? The conductor as well. It depends on the what? Temperature of the conductor. The higher the temperature of the conductor, the higher the resistivity it will offer to the flow of current. The higher the temperature of the conductor, the higher the resistance that wire will offer to the flow of current, the current that is flowing through it. So let's see that what? The electrical resistance, which is a constant of proportionality of this, is a constant, and it depends on the nature of the what? Wire, the dimension of the wire, the temperature of the what? The wire or the conductor. Then I will now come back and say full stop. Then coming here we say the potential difference, because we mentioned potential difference while we are defining the Ohm's law. Then what is potential difference? We say potential difference, this indicates the difference between 2 points as a regard their electrical states. Potential difference means that if something is moving from higher down, that means that has a potential difference. If for current to flow through a wire, there must be what? Potential difference. Just like for your tap to bring out water, for your tap, if you on your tap, for water to come up, there must be what? GP upstairs. This GP will now what? Create a potential difference. Assuming that you keep your GP down and put your tap to on, it will not bring out water unless you create what we call potential difference by taking your GP. Look at it. If you take your GP up and keep your GP up here and what? put your tap over here to take your tap, you see your tap will rush water. But if you take this GP down here, you will not see water rushing here. Reason, because by raising this GP up, you have created what we call potential difference. Water up there are coming down to what? To go through this place. But if you bring it in the same level of this what? The tap you want to take water from, there will not be any rushing out of the water. We now see that what we call potential difference. Potential difference means what? From the higher to the lower, or lower to the higher. That's what we call what? Potential difference. If there is no potential difference, there will not be any flow of current. So what causes the flow of current is what we call potential difference between the two ends of the wire. If there is no potential difference between the two ends of the wire, there will not be any flow of what? Current or electron. There will not be any flow of current or what? Electron. You know what we say when we say a flow of current, we are talking about flow of what? Electron. Electron flow is what we call current flow. Then when I say potential difference, this indicates the difference between 2 points as regard their electrical states. As regard their what? Electrical state. The other point is in higher in electrical state compared to the other one. Therefore, current will flow this way and come down from the higher electrical state to the lower electrical state. That's how the current flow. Then when I come back here, I say full stop. That is, it indicates the electrical state of what? A body. Electrical state of a body is indicated by what? Potential difference. And its unit is volt. The unit of what? Potential difference is what? Volt. And mathematically, what does it mean? Mathematically, I call potential difference or voltage drop. When we say potential difference, we are talking about voltage drop. So that when you hear voltage drop, we are talking about what? Potential difference. Voltage drop is equals to what? V, which is potential difference, equals to what? Current times what? R. This current times R become what we call voltage drop across this. That's it. This become the what? Voltage drop. That's what? The opposition which the resistance will offer to this current is what we call voltage drop. What the resistance consume is what we call voltage drop. And it's the same thing as what? Potential difference. So when I said potential difference between this wire, look at this wire, for current to flow like this, means that this place is in a higher what? Electrical potential. That is, this place is higher in electrical what? Potential. That's what to say in their electrical state. That means this place is in higher in electrical state. The where this place is what? Lower in electrical state. Current will flow this way. But if this place and this place are in the same electrical state, there will not be flow of current. There will not be what? Any flow of current. Therefore, we have seen what we call potential difference. Let's go into resistance. Don't be offended. We are trying to get you most of the thing you needed before solving the question. How we are going to be dealing in this particular class is that each question will take us to what we're supposed to know before solving the question. We are not going to go into solving the question without relating to things you needed to know before solving that question, because those things will help you for other questions that may come up on the same topic. So that's the reason why we are going through all this before the solving of the question. We come to what? Resistance, because we mentioned resistance in the definition of what? Ohms. We say resistance R is the opposition offered to the flow of electric current by a resistor or load in a circuit. I said a resistance is the opposition offered to the flow of electric currents by a resistor or load in a circuit. What does it mean? When we say load or resistor, just like when you have your phone, look at the battery of your phone. The battery of your phone is given as this, and your battery of your phone has internal resistance as this, and this is your battery of your phone, and this is EMF, which the battery produces. This R, small r, that's internal resistance. Look at the terminal of your what? Battery of your phone. If you now bring this battery and put in your phone will be connected to this battery, and your phone will become a load or resistor. Look at it. Your phone become what? A load or what? Resistor, which will be what? Consuming the current which this battery will what? Produce. By offering the opposition to that current, he begins to suck the current. And by so doing, this phone at a point will run this battery down. you have to charge it again. So when you remove this point, you take your battery away from your phone. If you slot the battery have to do work. What is the work it's going to do? By sending the current which your phone needed to be what? Alive. So by so doing, this your phone become load, which we call resistor, which is resisting the flow, because that current which this battery produce needed to pass and come back to the what? The battery back. This current needed to come back, that's pass through this and come back. But this man will offer opposition by consuming it. As it consuming it, the current that this man produces will continue what? Reducing. The voltage will be reducing. At a point, you have to charge the phone again. And that's what we mean by a load. We said resistance, which is a load, is the opposition offered to the flow of current. Flow of what? Electric current by a resistor. So there is something that produces current which this resistance offered what? Opposition to. And that thing that produces that current is what we call battery. And the battery produces direct current. You remember, battery could produce direct current. All the rechargeable lantern, rechargeable battery, all produce what? Direct current. Nickel battery. We have a battery called nickel battery. This one you call finger battery that you normally what? Use and throw away without recharging it. They are called what? So we see that this cannot be what? Charged. So now they produce direct current, and we have alternating current which is produced by generator. If you talk about alternating current, that's current that varies. It's produced by what? Generator. But it's direct current are produced by what? Battery. Then when I said here that what? I come over to say what? In a circuit, a good conductor such as gold is a good conductor, have low resistance, and a poor conductor will have what? A high resistance. A poor conductor has a what? High resistance, while good conductor has low resistance. That means a good conductor offer less negligible resistance to the flow of current. He offer opposition, negligible opposition to the flow of current. That's what we mean by low resistance. And the unit of resistance is what? Ohms. Look at the unit. It's called what? Ohms. We use the name, which is German what? George Ohms. Then when I use his name what? In memory of his name, that's why we use it as what? The unit of what? Resistance. We said what? Ohms. And the symbol is this. Look at it. The symbol is this. Mathematically, we said that resistance is equal to what? The voltage drop across the what? The resistance, the full, which is resistance what? X divided by current, which is what? Absorbed. This is the voltage drop divided by current will give me what? Resistance. Then we said note that, and I said note that, look at this circuit. This circuit, the battery, the ammeter, and what? Voltmeter. This is the ammeter, this is the battery, this is the current the battery produce, which pass through this. And ammeter is used to read out this battery current. The ammeter is used to read out what? Current that is flowing to this load. We use the ammeter to read current that is flowing to this load. And this ammeter is connected in series. Look at it, it's connected head to head, that is in series. We now say the ammeter is connected in series to read out the current that is being what? Supplied to this load. Look at the load R. Then voltmeter is connected in parallel to read the voltage drop across this what? Load. What do you mean by voltage drop? What this load, the opposition which this load offer, they will call what? The what it consumes. As this load is what? Consuming current. As this load is consuming current, it use current to survive. That current is consuming times the what? The resistance. Give me the voltage drop. And that voltage drop is what this voltmeter is used to read. Now let's go here. We now say what? Ammeter, which is this, is used to what? Measure or read out the value of the direct currents flowing through what? A closed circuit. Before ammeter can read a current, that circuit must be a closed circuit. Have you seen a closed circuit? If this circuit is open circuit, like me, I have a switch here, I open the switch. There will not be any reading. Ammeter will what? Read. There will not be any reading. Voltage will what? Read. Voltmeter will read. So this voltmeter and ammeter is used to read the voltage across the load and the current that passing through the load when the circuit is what? Closed. So we said it's used to read direct current flowing through the what? A closed circuit. The circuit must be what? Closed. Then I come back again to say ammeter is always connected in what? Series. Ammeter is always connected in series in a circuit. Why? Why ammeter is connected in series in a circuit? Due to it has a very low resistance, internal resistance. Ammeter has a very low internal resistance. So it has nothing to offer. It has no opposition to offer to the flow of current. Rather, he read the value of that current. He read the value of that current out. So it has no much resistance to offer to the flow of current. We said it is a very low internal resistance, and so as not to resist most of the current it is to measure. So it don't have nothing to he can't consume the current that is given to him to measure out. So he has no he has a low internal resistance. That's why it's always connected in series. Note it, ammeter is always connected in series, because it has a low internal resistance. So he have nothing to offer to the flow of current. Rather, he read it out for us to see the value. Then you come back here, we talk about voltmeter. Voltmeter, look at it, you see how it look like. You look at how we put it on, look at the terminal. Come here to see ammeter terminal. Look at ammeter terminal. It will be connect head to head. So it's in series. You connect in series to read. Then come over here to see the voltmeter. Voltmeter is connected this way. If I want to read the voltage or potential difference across a load, I have to put the voltmeter this way. Which is now, voltmeter is used to measure or read out the value of potential difference, which we call voltage. Are we there? We say voltmeter, this symbol, is used to measure or read out the value of potential difference, which we call voltage, across the two terminal. The two terminal. Look at the two terminal. Are you going to see that? When I put it here, it will read the potential difference. Whether the voltage is moving this way or this way, this man will read it for me and give me the actual value of voltage drop across this load. As we said, across the two terminals. Across the two terminals. Then we will now come back to say voltmeter. I come back to say voltmeter is always connected in parallel in a circuit due to it has very high internal resistance. Why? Why are we connecting this man in parallel? Because he has very high internal resistance. If we connect it in series, it will consume the current, the voltage you want him to even read out. So he will give you an error. Rather, if you connect it in parallel, you'll be able to get the actual voltage. But when you connect it in series, it will consume even what you want him to read. So we said it has a very high internal resistance, so that it does not draw much current in the circuit. That's why we connect it in parallel. We say voltmeter is always connected in parallel, because it has a very high internal resistance. That's the reason why we connect it in parallel, so that it will not consume that much current in the circuit. So that's why we connect this man in parallel. Then let us solve our question. Now, let's look at the question. After we have gathered all the necessary things we needed to know about this particular question, we said the question said 5 ohms resistors connected in parallel have a potential difference. We have already know what I mean by potential difference. Have a potential difference of 60 volts applied across the combination. Then they said full stop. The current in each resistor is what they ask us now, the current in each resistor. Before we go into solving it, let's look at this format we needed to know. This 3 resistor in parallel. Three resistor in parallel. This is R1. This is what? R1, R2, R3. This is R1, R2, R2, R3. They are in parallel. How did I know they are in parallel? How will I know that these 2 or 3 or more resistors are in parallel? How will I know? For me to know that 2 or more resistors are in parallel, this different current will flow through them. Means that different current or different charge will flow through them. The current that flow through them are not the same. Immediately the current that flow through them are not the same. I know that those people are connected in what? Parallel. Look at it. Look at this current now. The current are going in. Are you going to see? The flow. When the current flow from here, this is the current produced by this battery, is flowing now, going into the circuit. When you get here, what will happen? Then, look at what will happen. This current will split. Part of it will flow to this place. Part of it will flow to this place. Part of it will flow to this place. And this is what happened. This is current produced by this battery. It's entering into the circuit. Getting to this point, look at the point. Then some of the current will flow this way, which I call what? Current 1. Some will flow through this way, I call it current 2. And some will flow like this, call it current 3. And this current will come back here and come back to the what? The battery. Look at it. This one will come here and wait. This one will come and wait. This one will come and wait. They flow and come back to the battery. So when I have a different current flowing through a what? A resistors, 2 or more resistors. 2 or more resistors. When I have a different current flowing through what? 2 or more resistors. Those resistors are connected in parallel. Have you seen how I will know that a resistance is connected in parallel? When different current flow through them. The current that flow through them splits, and what? Different current flow through them. I will say they are in what? Parallel. Noted. Then now, this man is voltmeter, which we use to read the voltage drop across this R1. This is voltmeter 2, which is used to read voltage drop across this resistor 2. This is voltmeter 3, which is used to read voltage drop across this resistance what? 3. Now let me come again. This is voltage 1, voltmeter 1. I remember it 1, voltmeter 1. Is used to read the voltage drop across this what? The resistance 1. That's the what resistance 1 can consume, the current which it can consume, amount of the food is going to eat through this current. While this V2 is voltmeter 2, used to measure the voltage drop across R2. While this V3 is what? Voltmeter 3, used to measure the voltage across this what? R3. Then let me shock you. The voltage drop across this man and voltage drop across this man and voltage drop across this man are the same. If this voltage drop across this man is 20, this one will be 20, this one will be 20. That's the properties of what? Parallel connection. In parallel connection, voltage drop across each resistor are the same, but current that flow through them are not the same. I'm coming again. In parallel connection, the voltage drop across the what? Each of the resistor is the same, but current that flow through them are not the same. Then we now come back to say this voltage drops across each of these is equal to the what? Supply voltage. This is supply voltage. Just like at your home, you bring out your wire and connect to the what? High tension and low tension in your home. Another person from his own house will bring his own what? 16 mm and connect to the low tension. All of us begin to connect to low tension. What we are connected, we are in parallel to each other. So we now see, look at it, look at the tension. This man is connected here. Look at the voltage. Is supply here. This man hooked to this. This man hooked to this. Look at the voltage. You should call what? Potential difference. Look at potential difference this man will produce. Hook here. Look at the end. Look at the end. And this man now tap from it. This man tap from it. This man tap from it. So the voltage supply are the same. Voltage across each of these people are the same with what? Voltage supply. And that's what I started here to note it for you. Come over here. I noted this to you. Said V, which is voltage supply, is equal to voltage drop across resistance 1 and is equal to voltage drop across resistance 2 and equal to voltage drop across resistance 3. And I come back to tell you why the voltage drop across resistance 1 is voltage drop across resistance 1 is equal to resistance 1 times current 1. Look at it. This current now times this man will give you voltage drop. This is what this man will read. Are you going to see? That's what voltmeter 1 will read. Voltmeter 1 will read current times R1. Voltmeter 2 will read what? Current 2 times R2, which is voltage drop across R2. Then voltmeter 3 will read what? Current 3 times R3, which is voltage drop across what? R3. Then we will now say it again that since this man is equal to this, we will now carry this man to substitute here, carry this man to substitute here, carry this man to substitute here. We have this that V is equal to what? Current 1 times R1 is equal to current 2 times R2 is equal to current 3 times R3. Since this man is equal to this, look at it. I remove this man now, carry this man, put here, look at it. I remove what? This man now, carry this man, put here, have this. I remove this man now, carry this man, put here, have this. Have you seen it now? See the V is equal to what? Voltage drop across this and voltage drop equals to voltage drop across this equals to voltage drop across this. That means voltage drop across this man and this man and this man are equal to the what? Voltage supply. Then another condition, we say that current are not the same. Since current are not the same, the total current, which is this, look at the total current. Come over here. Look at the total current. The total current is equal to current that goes to the what? R1 plus current that goes to what? R2 plus current that goes to what? R3. That's what we say current, total current is equal to current 1 plus current 2 plus current 3. Will give me what? The total current. Because this total current is what splitted here and go here and go here. And when we add it to up, it will give us the total what? Current that what? Flow. Then now we'll come back here to tell you that current 1. Pay attention seriously here. That's where Jam and Wayek will confuse you. Current 1, which is this, are not equal to current 2. Current 2 are not equal to current 3. This man are not equal to current 2. This man are not equal to current 3. They are not equal. Then they will only be equal. Pay attention. This man will be equal to current 2 and current 2 will be equal to current 3 only if R1, R2, R3 are the same. That's the condition they give us here. Are you following? This current 1 and current 2, current 3 will be equal to each other only if R1, R2, R3 are the same. Look at it. They say 5 ohms. That means the resistance are equal. That means R1, R2, R3 are the same, which is 5 ohms. Therefore, current 1 will be equal to current 2. Current 2 will be equal to current 3. But let's go to what? The question. Come over here. We'll come back to the question to solve it. Look at it. Resistance in parallel. 3 resistance, 55 ohms is in parallel. That's what they asked us there. First 5 ohms, 5 ohms, 5 ohms. You see that the resistance are equal. That's resistance 1 is equal to resistance 2 and is equal to resistance 3. Therefore, current that flow through this man is same thing as current this one, current 2. And this current 2 is same thing as current 3. This current 1 is equal to current 2. Current 2 is equal to current 3. Reason, because these resistance are the same. The same current will flow through them. Then now, let us go into calculation. We now say the voltage across it, the potential difference across it is what? 60 volts. Look at it. Potential difference across it is 60 volts. We'll stop. We will put it here. But let's say, we'll now come to what? Voltage drop across what? This man. This 5 ohms. I will say current 1 times R1 is equal to what? 60 volts. Because this voltage drop across this is equal to 60 volts. Voltage drop across this man is equal to 60 volts. Voltage drop across this man is equal to 60 volts. And I choose this one. Say voltage drop across what? This man, the first one. I say current 1 times R1 is equal to 60 volts. And I said making current 1 subject of formula become what? R1 at 60 volts divided by R1. And what is R1? 5 ohms. I put 5 ohms. 5 ohms divided by 60. It gives me 12 ampere. It gives me what? 12 ampere. Because R1 is what? 5 ohms. And the current, which is this, which I'm looking for, is equal to what? This voltage divided by what? R1. And R1 is what? 5 ohms. It gives me 12. Or I can choose to say voltage drop across this, which is what? Voltage drop across what? R2. And I say V2 is equal to current 2 times R2. And the same thing is equal to what? 60 volts. And I say equals to. And I'm making what? R2 subject of formula by dividing 2 by what? R2. I will now have R current 2 equals to what? V2 divided by R2. How did I do that? By dividing 2 by what? R2. The same thing I did here by dividing 2 by what? R1. I will now divide this one by R1. Divide this one by R1. I have this. R1 divided this current 1 R1 will give me current 1. Then what I will have here is 60 divided by R1. Then what is R1? 5 ohms. I put it here. Divided by 60 give me 12 ampere. Or somebody choose to say this one. I said what? V2, which is voltmeter 2. We read what? Current 2 times R2. And it give me what? The same thing as what? 60 volts. And I say making what? R and current 2 subject of formula. I will divide 2 by R2. Dividing 2 by R2, I will have now this divided by R2 will kill itself, giving you towards current 2. Then V2 will be divided by R2. And what is the V2? The same as what? 60 volts. I will not say 60 volts divided by 5 ohms will give me what? 12. Or you can also choose it to be what? Again, choosing this man, it will still give you something, the same thing. I'll say V3 is equals to what? Current what? 3, R what? 3. And making current 3 is subject of formula divided by R3, I will have current 3 is equals to what? V3 divided by what? R what? 3. And what is the V3? V3 is same thing as what? 60 volts they give me, which will give me what? 60 volts. And R3 is what? 5 ohms, which is, look at it. And that will give me what? This is equals to what? 12 what? Ampere. And when you add this and this and this, add this total current, it will give you this total current that is here. And if you want to know, it will give me what? Total current that is here. Look at it. If I want to add it now, it will give me total current that is here. I will say total current equals to 12 volts plus 12 ampere plus 12 ampere plus what? 12 ampere. And that will give me what? 36 watt. 36 watt ampere. That's the total current. And if I want to confirm this, whether this total current is the same or whether this total current works here, I want to know, I can now calculate the total resistance here divided by what? The voltage. My option is option C. That's my answer. Look at the option there. Option what? C is my what? Answer. Look at it, which is what? 12 ampere. And what we have here is what? 12 ampere. Thank you. If you have not subscribed to this channel, endeavor to subscribe.